Hello. I thought I would do another puzzle. This one is called Colorado 8 by Florian Wortmann. And I don't know too much about it. I got it off Cracking the Cryptic. But it looks from the site like this one's about 270 days old, and which is probably about 3/4 of a year. And there are about 12,000 solvers. There are 11,961 solvers. So I guess I'm determined to be the 11,962nd if I can. And what I will do is I'll start the puzzle and I will read the rules. So, normal Sudoku rules apply. Cells connected by an X contain digits summing to 10. Cells connected by a V contain digits summing to 5. Not all possible X's and V's are given. Clues outside of the grid give the sum of the first X cells in the corresponding column, where X is the digit in the nearest clue. Okay. So, where do I want to start? Where do I want to start with this? Well, we could look at the rules. Does it say not? Yeah. So, I've seen these before where they give you an X or a V in between cells, and those cells add to, in this case, 5, or in this case, 10. So they're little Roman numerals. And that's one of the rules that we're given, or one combination of the rules. The second rule that we're given has to do with this 37. There's going to be a number here. Maybe that number is 5, for example. And then the sum of the first 5 digits in that row will need to equal 37. So, with that, I think we can start thinking more than we already are. So I guess I know a couple of things. Maybe this isn't the place to start, but I think I know a couple of things about this cell. This cell is probably bounded from above and below. So what can this not be? This can't be a 1, for example, because then we would only sum up the first digit it sees, which is 1. This can't be a 2, because then maybe I could put a 9 in here and I would get to 11. But that can't be a 2. It can be a 3. If it's a 3, then I could put a 9 and an 8 after it, and that would sum to 20, which is still too low. If this was a 4, I could put a 7, 8, and 9 after it here. This 7, 8, and 9 would sum with the 4 together to be 4 plus 7 plus 9 is 20, and then 28. So if this was a 4, I could make this at most 28, which isn't allowed. So this cell is not allowed to be a 1, 2, 3, or 4. Could it be a 5? If this was a 5, I could have 5, 6, 7, 8, 9. So 11, 20, and then another 15 would be 35. So you're not even allowed to be 5. You need to be at least 6. And then I think with 6, we may be able to do it. So with 6, I could have after you 9, 8, 7, and 5, and 4. Would this add up to a number greater than 37? Let's see. So you guys together sum to be 23, 39. So yes, so you're allowed to be a 6. You are allowed to be a 6. You're not allowed to be a 9, because then the sum of all of these digits would need to be 37. Excuse me. Well, if you were, yes. So the sum of all the digits in this column needs to be 45, because that's the sum of the digits from 1 to 9. So you can't be a 9, because then the sum of the column's first 9 digits would be 45 altogether. So you can only be, I don't know if this is the place to start, a 6, 7, or 8. But I kind of want to rule out 8 even. So if you're an 8, then what would happen would be the sum of the first 8 cells would need to be 37. The sum of all 9 cells needs to be 45, but the difference is an 8. So this would need, if this was an 8, then we would put in all of the numbers. We would put in some numbers here, but this would need to be an 8 too. So you're not allowed to be an 8. And now I kind of wonder whether or not you're allowed to be a 7. We've gone through every option, and I feel like maybe or maybe not that's the place to start. This might be a bit of a distraction, but let's see. You can't be anything but a 6 or a 7. I don't know if that's the place to start. Maybe, I mean... Yeah, I don't know. You need to be a 6 or a 7. If you were a 7, then the first 7 numbers would need to add to 37. This is allowed. This is allowed. I could try applying that 45 sum rule someplace else, now that we're dealing with sums. So, for example, in this region, all of the cells together will sum to 9. Or, excuse me, will sum to 45, because 45 is the sum of the digits 1 through 9 once. But you together need to sum to 10, you together need to sum to 10, and you need to sum to 5, which means you 3 need to sum to 20. And that is pretty prohibitive. So you're not allowed to have a 1 in you. Are you allowed to have a 2 in you? No. So the 1 and the 2 must go out here. But it is possible with a 3, an 8, and a 9. But I know, definitely, that somewhere out here is where the 1 and the 2 go. That is helpful-ish. I don't know. I don't know if that's helpful yet. We're just sort of moving around the puzzle and thinking about the rules and what we know. Something else? So, this is a rule we can apply. There are only certain numbers that go in V's. I can't put a 5 in the V or anything higher than that. If this was a 5, we would need a number here such that it sums to 5 with the other number. So you would need to be a 0. And that's not allowed. I'm only allowed to use the numbers 1 through 4 in the V's. And there are 4 cells in this region which have V's in them, or are connected by V's. So you need to definitely be the numbers 1, 2, 3, and 4. And now you guys, you definitely need to be the numbers 6, 7, 5, 6, 7, 8, and 9. That seems like it was helpful. That seems like it was helpful. You can't be a 5 because then you would need to be a 5, so you're not allowed to be a 5. If you were a 6, then you would need to be a 4. I wonder, if this was a 6, it sort of would, it seems like it would influence this column quite a bit. In fact, it would influence a lot of this stuff, I think. I'm not sure. There's also this interesting pattern here. So say you were a 6, then you would need to be a 4. You would then need to be a 1, and you would need to be a 9. So these two cells together, do they need to sum to 15 or something like that? Let's try this again. If you were a 7, you would need to be a 3. You would then need to be 2, and you would need to be an 8. So these two cells together need to sum to 15. And what that means is that you can only be a 6, 7, 8, or 9 as well. You can only be a 6, 7, 8, or 9. And then, of course, you could only be the numbers 1, 2, 3, and 4. 4 pairs with 6, pairs with 1, pairs with 9. So that's interesting. That's interesting too. So that's interesting. Am I using all of the rules here? I'm 8 minutes into the puzzle, and I've filled in a lot of small numbers. I've used a lot of notation on the puzzle, but I don't know where any of the big numbers go, any of the real numbers. Normal Sudoku rules apply. Cells connected by an X contain digits summing to 10. Cells connected by a V contain digits summing to 5. Not all possible X's and V's are given. Clues outside of the grid give the sums of the first X cells in the corresponding column where X is is the digit in the cell nearest to the clue. So you can only be a 6 or a 7. That influences what you guys can be. We could think about what happens if you're a 6 and try to rule out that possibility. That would then rule out 4 as a possibility here. I don't know if that's the way to go. Here is another cell. Here is another region, rather, that has 2 V's in it. This V and this V, they're entirely contained inside the region. And what we know about that in that case is that you guys, you need to be 1, 2, 3, and 4. Maybe I should use the small. 1, 2, 3, and 4. Maybe that's what I should do. Maybe I should use the colors and think about the numbers 1 through 4. I'm not quite sure, but say, let's call this a green cell, and let's call this a yellow cell. So I don't know what numbers yellow and green correspond to, but wherever I place a yellow in the future, if I solve for one of the yellows, then all of the yellow cells will need to be that. So you could think maybe yellow is 2. In this case, this would be 3, and in this case, this would be 2. You need to be a yellow cell, because yellow plus green is going to be equal to 5. That's sort of how we've set it up. Now, there are only 2 ways. There are only 2 ways of making. There are only 2 possible ways of making 5. I could use 2 and a 4, 2 and a 3, or 1 and a 4. The combinations. There's a second way, and that would fall down here, probably. So if we think about this, you could be red, for example, and then you would be blue. So now we have 4 colors. Now what happens? So we don't know whether the colors, we've got 4 numbers and 4 colors. Red, blue, yellow, and green are our colors, and 1, 2, 3, and 4 are our numbers. They have interesting pairings. So you two, you can't be a yellow or a green. You would need to be red or blue, and this means you would need to be red or blue. This would mean that you guys need to be green and yellow. You need to be green and yellow. Now you're not allowed to be red or blue, which means you two together need to be yellow and green. You're not allowed to be yellow, so you would need to be green, and now you would need to be yellow. Now you're not allowed to be yellow and green, so you need to be red and blue in some order. You're not allowed to contain a yellow cell at all, so you also need to be red and blue in some order. Now what? What? Well, what should I do? You are not allowed to be a green, so you need to be red and blue. You're not allowed to contain a green, so you need to contain red and blue. You need to contain yellow and green. I don't know. I don't know if this is... I feel like we learned some things, but not other things. I don't know. I do not know. I don't think it's possible now for you to be a blue cell. Because let's say blue is 1, for example, then you would need to be a 9. Now, say this was a blue cell. This would be a 1. Then this would need to be a 9. These two cross out, or they cause a contradiction. So you can't be blue, because this would create 2 cells that see one another and are equal. You need to be red. And now you need to be blue. I wonder if we could apply that some where else or somehow. Let's see. The thing that I'm realizing up here now is we have this U2 sum to 5. And that means you must have a 1 or a 2. You must be 1 or 4, or 2 and 3. So we've written that the 1 can sort of go anywhere, and the 2's in the ones they need to go. I mean, I sort of left a big hole. The 1's and the 2's could go in any of these cells. But at the end of the day, we're going to figure out that a 1 or a 2 must go in one of these cells. One or a 2 must go in one of these cells. I'm just not sure. There needs to be a yellow somewhere in this column. There needs to be a yellow somewhere in this box. But these regions see yellow along the column, so you must be yellow. And now, yeah, so we know some things about the yellow cells. There must be a yellow in one of these two. I don't know whether I should use more than one. I don't know whether I should take my color notation and allow it to describe two. I don't know whether I should color both of these yellow or not. That might just be a confusion, I guess what I'm saying. There needs to be a green in here someplace. Green can't go in these two because these see green along the row. It can't go in these because they're taken up by other numbers. So a green must go in here someplace. In fact, if you think about this column, there's very few places that a green cell could go. I guess green's allowed to go here, here, something like that. Can we make something about how these ones are connected to one another? Like, say this, you need to be the same as you, I think. Say you're a 1. You would need to be a 9, now you would need to be a 1. So you can only be green or yellow as well. You are not allowed to be green or yellow. You are not allowed to be green or yellow either. So we need to put greens and yellows in this column. Where is the yellow allowed to go? It's not allowed to go here. In fact, yeah, yellow is not allowed to go here. Yellow is not allowed to go here. Yellow must appear either here or here. I wonder what should I do? Should I add more colors? Should I start thinking about the 10s and stuff like that? The 10 sums? So for example, if this was a 1, we would have 1 and 4. This would mean this would need to be a 4. This would need to be a 6, and this would need to be a 9. So I think, using our reasoning, these two need to sum to be 15 also. These two need to sum to be 15. And we have that up here, too. You need to sum to be 15, too. U2 are actually the same two numbers as U2. Now that I think about it. Fun puzzle, hard puzzle. 20 minutes in, and I've put some colors down. It's called Colorado 8. I wonder why it's called Colorado 8. I don't see anything about Colorado or the number 8 yet. Although maybe 8 plays some role somewhere. Let's see. Now is it possible to figure out what you need to be, now that we have all these colors drawn out? Let's say you were a 6. Let's say you were a... How do we do this? If you were a 6, say you were a 6, then the sum of these digits would need to be 37. And one of them needs to be at most 4. So what could we have? We could have a 6 here. We could have a 4 here. I'm screwing this all up, so don't focus on it too hard. But then I think there is a contradiction in there. I don't know how I should do this. So if you're a 6, then the sum of these digits needs to be 37. So there are 5 digits to place. One of them needs to be at most 4. At most 4. We need to add to 37. Anyway, if you're a 6, then we could do something like 4. This would make this a 1. We could do something like this. I mean, we could do something like you're not allowed to be a 9 because you pair with this. So you'd be like an 8 or a 7. I don't know if I don't know what I said, but it's sort of a snow day here. I'm tired and I'm in my pajamas, and it's there's like 6 inches of snow outside, which makes doing a puzzle seem like a lot of fun, but or it is a lot of fun. But I don't know if my brain is acute enough to hold all of this in my head at the same time. Anyway, if you were a 7, then U2 at most could add to 7. So now we would have 14 here. If this was a 3 and a 4, and this was a 7. Why am I doing at most? Maybe I should do at least. If you were a 7, then U2 would need to be at least 3. So then I could have 10, right? I'm confusing myself. I don't want to fill in the numbers because I'm only going to get more confused in that instance, but... Okay, forget that. You need to add to 10. So if you're a 7, then we have 7, 10, right? I wanna do this I want to do this algebra, but I'm having difficulty holding it all in my head. Let's see. Is it possible for you to be a 6? If you're a 6, then okay, so how do I need to do this? I need to figure out what the minimum possible sum is here and then show that the minimum sum is over 37. Or I need to do the maximum possible sum and show that it's under 37. I think that's what I need to do. So if you're a 6, then the maximum possible sum for these cells is what? You could be a 9 and you could be an 8. You could be a 4. So together these would be 21. I don't actually know if that's possible because then, yeah, it's possible. So you could be a 4, 9, and 8, 21, 27. U2 would need to add to 10. U2 would need to add to 10 as well. And I guess you could be maybe 7 and 3. Okay, I'm going to give up on trying to rule out one of those cases. I'm going to look for something else which would tell me about the distribution of red and blue and yellow and green cells, and I think maybe that will make ruling out one of those options easier. Maybe that will make ruling out one of those options easier. So now I want to look at this. I want to look at these. There needs to be a number here that pairs with a red cell to make 10. So say the red was 4, then this would be 6. Now the question is, okay, so this cell can't go here. It would need to go up here someplace. So now one of you two could be pink. One of you two would need to be the pink cell. Whatever goes in here needs to go either here or here. It's the same thing here, right? I don't know if these cells are yellow or green, but whatever you are, you're going to be an orange, right? You need to pair with the yellow and the green to make 10. The yellow or the green to make 10. And I know that orange is different than pink because of the fact that they sum with different numbers to 10. And I also know that they're different than the other colors I put down because you need to be greater than 6. You need to be 6, 7, 8, or 9. So now the orange cell would also need to go up here. If you think about that, because in this region the orange cell wouldn't be allowed. But the orange can't go here. Can't go here because you need to pair with a red or a blue to make 10. So you now need to be our pink cell, and you now need to be our orange cell, whatever that is. And you need to be a red cell, and you need to be a blue cell. Okay. I don't know whether or not the pink and the orange cells are going to come in handy or whether or not we're going to need to remove them to think about something else. But what we've just shown is that this needs to definitely be red. And I think that is illuminating. Whatever is red and blue here, this needs to be red and blue here. Okay, so now a red cell needs to go in this region. It needs to go in this region. It can't go here. You guys see red along the row. You see red along the column. You see the reds here and here. So one of you two must be a red cell. But if the red cell went here, then I would need a pink cell here. This would cause a contradiction. So you must be red. You must be red. I need a red cell up here somewhere. The orange it was only helpful a little bit, but we actually did get something out of the pink cells. Maybe I should leave these colors in. So the red, the blue, the yellow, and the green, these are definitely the numbers 1, 2, 3, and 4. We don't know the locations of all of these colors. We don't know what numbers go in the colors. Pink is a cell that we've defined to be 10 minus the red cell. And orange is defined by sort of we don't know what orange is. Orange is either 10 minus green or 10 minus yellow. But we don't know. But we know some new locations of some red cells, and that makes us happy. There needs to be a red cell up here someplace. It needs to go in one of these two. If this was red, then this would need to be pink. Yeah. In fact, I could even add another color. I could call this one, is there a color left? I don't think there's a color left. I could use gray. Gray is going to be defined to be the cell that pairs with blue to make 10. So you can be gray. Now I need like a gray cell up here. You guys see gray along the rows and columns. If you were a gray, then you would need to be blue because gray pairs with blue to make 10. So you need to be our gray cell. We don't know where any of the numbers go, but we don't know where any of the numbers go, but we know where the colors kind of go. There needs to be a gray in this region, but these cells see gray along the rows. If this was a gray cell, this would need to be a blue cell. That would cause a contradiction. So you need to be gray. This is getting very colorful. Very, very colorful. So what are our numbers and colors? Red, blue, yellow, and green are definitely the numbers 2, 3, and 4. Gray, pink, and orange are definitely the numbers 6, 7, 8, 9. So where does we still don't know where 5s go. One of you guys must be a 5, by the way. You're not allowed to be a 5 anymore. One of you must be a 5. I feel good about this. I feel like we've made progress. But there's more progress to be made. So where does a blue need to go in this region? The blue can't go here and here because you see a blue along the column. The blue can't go here or here because that would put a gray into one of these. So the blue needs to go here. One of you must be a blue. And the result of that, I'm going to take this out because I don't want to color 2 cells at once with the same color unless I know what the pair is. But if one of you two must be a blue, then you can't be a blue. You must be red. And now you must be blue. It's the only thing, it's the only way it works. And now, can we do this all again? There needs to be a blue cell down here someplace. You see blues along the columns. You see a blue. You can't be a blue because you're a 6 or a 7. You see a blue because of the X. If I put a blue here, then then a gray cell would need to go here, and that creates a contradiction. So you are our missing blue cell. There needs to be a blue cell up here someplace. These see blues along the columns. Putting a blue here would create a gray cell there, so you need to be blue, and now you need to be red, and you need to be blue. And now I feel like we've just made a bunch of progress. So in this region there must be a blue. That blue can't go here and here because you see blues along the rows. It can't go here because of the X. You would then see a gray, and it can't go here because there's a blue up there. So you need to be blue. And now there's a blue in this region. That blue must go here. And I think that is all of the blue cells. We don't know what goes in the blue cells, but as soon as we do, as soon as we know one of them, we know all of them. But we've placed all of the blue cells. Can we place the red cells? Red cells are going to pair with pink to make 10. So where can I apply that? Red cells are going to pair with pink to make 10. That means that the pink can't go in any of these ones. Pink must go here or here. If a pink went here, then this would need to be red. That seems allowed. If a pink went here, then anything goes. And anything goes, I think by definition, is allowed. Let's see. Let's see. More? I want to know. We figured out the locations of all the blue cells. We haven't figured out which of these are yellow and green yet. So I wonder if we can do that somehow. We've put down 7 colors. You need a yellow in you. This region needs a yellow in it. And that yellow can only go here or here. If you were yellow, then what would happen? You maybe could be orange. I just don't know. Is there something I'm missing with the red? So there needs to be a red up here someplace. Reds, you guys see red along the rows. You see a red along the column, so you must be red. And now, because red pairs with pink to make 10, you need to be pink. Okay. Okay, still going. Still going with the colors. No numbers yet. We can only use these colors. This is a lot of fun. Florian, thanks for the puzzle. Let's see. You need a gray cell in this row. Can't go here, and it can't go here because you see grays along the column. So that gray needs to go here or here. Gray pairs with blue to make 10. So if this was gray, then you would need to be blue, and that would cause a contradiction. So you must be gray. You must be gray. This is turned. I don't know what this has turned into. I'm learning now that this. I've never really seen a puzzle, I don't think, with the X's and the V's that is so extensive, for lack of a better word. I've never seen a puzzle where you can just fill in all of them, or rather use color so long. Like what this puzzle is sort of created is a situation where we know where colors go, and we know that colors correspond to numbers, and we've been able to put in tons and tons and tons and tons of colors without placing any numbers. It's interesting. All right. You need a red. This region needs a red in it. That red can't go here or here, so one of you must be red. And this means one of you two must be pink, because red pairs with pink to make 10. So now I need a pink in this region. You cells see pink along the rows, and you see pink along the columns, which means you need to be a pink. Now I need pink in this region someplace. You see pink along the columns. You guys are other colors. If this was a pink, then you would need to be red. So you need to be pink. Jeez. Yeah. Crazy. Crazy, crazy. What else? What else? You are an orange. You two are going to be the same color. I want to get back to the green and the yellow. These are the first colors that we put down, but I just haven't figured out how to use them, apply them at all, really, since we started. And then there are some X's that we just don't know anything about up here. So I guess you must have... The thing about the X's is that they can't be 5 and 5. because this would create a contradiction. They need to sum to 10. We need to put two numbers in here, and I can't use 5 and 5 because then these 5s would see one another, which means I must use in one of these cells a number that is in each of these. In each of these cells, I need at least one number that is 4 or below. So this could be 4 and 6. This could be 3 and 7, but in both instances, they use a number that is, at least one of them uses a number that's below 4. So this cell, U, for example, U can't be yellow or green. U also can't be red or blue. So U need to be a number that's below 4. U can only be yellow or green. I think I can do the same thing, something like this down here. I need a number that's less than 4 in this region. I can't use the red or the blue cells, which means that the missing piece here is green. A green needs to go in one of these two. And if a green needs to go in one of these two, then U need to be yellow. Now, U need to be green and U need to be yellow. U need to be yellow too. Great. So now what we know is that orange pairs with yellow to make 10. So you need to be an orange cell. One of you two must have a green in U. And we don't have a number that pairs with green yet. Maybe I should put one in. I'm going to use all the colors. I'm going to use all 9 colors before I place any numbers. And I think if I do this long enough, I'm going to get something about what this needs to be. And that's going to fill in everything else. I think there needs to be a green in here someplace. If there needs to be a green in here someplace, then U must be a green. And if U must be a green, then U must be a yellow. So now U must be green. Lots of progress with the colors. 41 minutes into the puzzle, still no numbers. This is quite a puzzle. I really like this. Yeah, what to do? I need to figure out where the rest of them go. All right, so do we have all of the yellows in yet? We don't. You need a yellow. That yellow needs to go here, and yellow needs to pair with orange to make 10. So you need to be an orange cell. Now we need an orange cell up here, so you need to be orange. Now we need an orange in this region. Orange can't go here because you see orange along the row, but you can't be an orange because orange needs to pair with yellow to make 10, so you need to be an orange. I want to see if we can get away without using the last 2 colors. Maybe we can't. Maybe we can't. But the thing about this is as soon as we figure out at the end, I think at the very end, we're going to have some realizations about what the numbers need to be, and then filling in one number is going to fill in this whole puzzle because we're going to know where all of the numbers go beforehand using the colors. So yeah. So an orange needs to go in this region someplace. You see orange along the row. You see orange along the column. Orange pairs with yellow to make 10. So you're not allowed to be an orange. You need to be an orange. Now we need an orange in this region. It needs to go here. Now we need an orange in this region. It needs to go here. So I think now we have all of the orange cells. Do we have all of the yellow cells? We have all of the yellow cells. Do we have all of the red cells? We don't have all of the red cells. There are some missing red cells. So what? So one of you needs to be red. Gray cells. I don't think we have all of the gray cells. What do I know about gray? It pairs with a blue cell to make 10. So what that means is that the gray needs to be down here because you're not allowed to be gray. Actually, I feel like we're running out of situations where we can add to 10. Now that I think about it. What do we know adds to 10? What colors are available for these two? Well, I can't use an orange or a yellow. Can't use an orange or a yellow. I can't use a blue, and then I can't use a gray. So I think what this means, let's see, I need a gray cell somewhere in this region. That gray cell I don't think can go here and here because gray definitely pairs with blue to make 10. So one of you two must be a gray. Now one of you two must be a gray, and one of you two must be a gray. Maybe if I fill in the last two colors up here and here, I'll see some things. So, do I use black? Am I going to bring an 8th color into this? An 8th and a 9th color? What's the color I'm missing here before I do that? Gray. Gray needs to go here or here. What am I missing up here? One of you two needs to be green. And green pairs with this mystery number. So I think what we're going to need to do is we're going to need to add another color. Black. We'll call that black. Black and green are going to pair to be 10. Now there needs to be a black square here someplace. That black square can't go here. It needs to go here. So you're a black square. Now I need some numbers up here. This, I think we've established that this needs to be green and black. You must, I think, be green and black, is I think what we've determined. Whatever that shakes out to be. And then the missing color that's in here is pink. This pink cell needs to go here. Pink pairs with red to make 10, so you need to be red. And now you're not allowed to be green, which means you're not allowed to be black. But you are allowed to be black, which would make you green. You would be black. I think we're going to fill in this entire puzzle before we figure out any of the numbers. But it's going to, I don't know what that's going to do. I don't know what that's going to do. There needs to be a pink cell here someplace. That pink cell needs to go here. There needs to be a pink cell here someplace. That means that this is going to be a pink and a red. The red can't go here, so you need to be a red, so you need to be a pink. I need some other, we're using like all of the colors. Every one. There needs to be a pink cell in this region. That pink cell needs to go here. What else am I missing? There needs to be a green and a black. So you must be green and black. But I don't know what. I don't know which is which. There needs to be a black cell in here someplace. And what's the other missing number that goes in here with you? Let's see. What am I missing? In this column, we've used all the colors. So if we've used red, blue, yellow, green, pink, orange, gray and black, and white are missing. Gray and black and white, but you need to be white. So you two can be gray and black. Those are the options for you. When you add to 10, you need a number 4 or below. So you must be green and black. You must be green and black. This is going to create 2 rows that have 2 black cells in them. So now you must be green. And now you must be black. Now you must be green. You must be black. You must be gray. And you must be black. Now you must be green. I'm missing a gray cell down here. I don't know where that's going to go. I have a column that's almost filled up. This is missing a black and a white. This is missing a black, a white, and a gray cell. So you're not allowed to be a gray cell. You can be all sorts of things. This is missing a gray cell too. So I think what I've determined now is that you're missing a gray and a white. So you have to be a gray or a white, both of you. White or gray. You're not allowed to be a gray, which means that a gray and a black, one gray definitely needs to go down here someplace. All right, that was a wasted effort. Let's remove that because that's confusing. All right, the rows, can we do more with the rows? What am I missing? I'm missing a gray. The gray needs to go here. What am I missing in this one? Still just missing that one. This needs a gray and a black. The black isn't allowed to go here. The black must go in one of these two. But we're almost all filled up. Need a white and a black in this. Am I missing something? Am I missing something? We've almost filled in all of the squares with puzzles, or we've almost filled in all of the cells with colors. We're like 50 minutes in. We still haven't placed a single number, but this has been really fun and interesting to do. I wonder if we should start. I wonder how other people started trying to solve this. I wonder if this is the way of doing it, or if there was a way to place numbers earlier, and if there was, then it would have sort of you know, if there was, then this approach would just be crazy. It looks like I've sort of stalled out there on camera for a moment. I wonder if that's been happening a lot. Let me, here's what I can try to do. So, sorry about that. I just had some technical difficulties with the recording. And, you know, they may still even persist. It looks like, I don't know how this video is going to go, but maybe it won't get posted. But we'll see. Hopefully that isn't too big a distraction. Maybe the time went up a little bit, but I don't know if in the last few minutes I've made any progress. Where I left off, I had all these colors, and basically each of the colors corresponds to one number. We know that the green and the yellow and the red and the blue are definitely the numbers 1, 2, 3, and 4. The other numbers, the other colors, are black, gray, orange, and pink. And our rules for these numbers are as follows. Pink definitely pairs with red to make 10. Orange definitely pairs with yellow to make 10. Blue definitely pairs with gray to make 10. And black definitely pairs with green to make 10. And now that I'm restating the rules, I'm realizing something, which is that you're not allowed to pair to make 10 and be the number 5. Right? So if this was a 5, then this, you know, we're not allowed to have 5s in any of the numbers that pair to 10. So I think what that means, so what does that mean? So so yellow and green, blue and red, these are all numbers that we knew were less than 5. Now, black and gray, orange and pink, are numbers that we now know are greater than 5. So this means that the remaining white cells are our 5s. That's funny. I didn't restart the video. I had to pause due to technical difficulties, and then as soon as we turned it back on, I think we got some numbers. I think that these white cells need to be 5s. And now none of you are allowed to be 5. So, yeah. Cool. So now there needs to be a 5 down here. And that definitely goes here. I think this is how we're going to do it. Maybe. I don't know. This is our missing white cell. What do you need to be? That's a very good question. It's a very good question. You need to be gray. Because you're not allowed to be any of the other colors. You're not allowed to be a 5, so you need to be gray. You need to be gray. Now you need to be gray. Remove that. You need to be gray. And now what goes in here and here is definitely a white and a black cell. So this is definitely white and black. So one of these are going to be a 5. Somehow I removed 5 from this, but I shouldn't have done that. There needs to be a 5, and it needs to go here. But now I feel like the numbers are actually going to be less helpful. What I feel like we should do is think about the fact that gray needs to be 6 or 7. So gray needs to be 6 or 7. This means any place that we see a gray, we can only have 6 or 7. So what should I do? I should highlight all of the gray cells, and you guys are definitely 6 and 7. I know that gray pairs with a blue to make 10. This means that all of our blue cells, you can only be 4 or 3. Now we have red cells. Okay, I should really just, what should I do? I should maybe remove all of the numbers and start again, all of the little numbers at least. Can I do that? Because now I feel like we've opened up what the possibilities are for all of the, or we've really narrowed down the possibilities, I think, for what all the cells need to be. So blue, yeah, you're red. Let's remove your numbers too. So we started with this needs to be gray, this needs to be 6 or 7. This means blue needs to pair with gray to make 10. You need to be a 3 or a 4. Now red needs to pair with blue to make 5. So you need to be either a 2 or a 1. In fact, all of the red cells need to either be a 2 or a 1. Okay, now red pairs with pink to make 10. So all of the pink cells, you can either be 8 or 9. 8 or 9. I used the wrong numbers here. You should be the little numbers. You should be 1 or 2. Let's see. Is that all we have? Is that all we have? I think that's all we have. I sort of keep skipping very early in the puzzle. We're about to cross the 1 hour mark, but very early in the puzzle, very, very early in the puzzle, I was dealing with, like, can this be a 6 or a 7? That's really what we just need to deal with it now, is I think the thing. We just need to deal with it now. We need to go through all the we don't need to go through all the possibilities. There's only 2 possibilities. We need to rule out one of them. So is it possible for this to be a 6? Is it possible for this to be a 7? If you were a 7, then you would need to add to 37, which means you would need to add to 30. You would need to add to 20. You would need to add to 20. One of these is at most 4, which means the minimum that you can add to is 16, and there's 3 numbers, one of which is less than 4, one of which is greater than 4. Oh, this is difficult. So what can you be? You can be a 1, 2, 3, or 4, I think. If you were a 1 and 4, then you would be a 2 and a 3. Something like that. You can be a 5, 6, 7, 8, or 9. You can be a 5 because you're allowed to be a white cell. You can only be a 6, 7, 8, or 9. And you are only allowed to be a 1, 2, 3, or 4. So now maybe this will be a little bit easier on myself. Maybe this will be a little bit easier. What we should do is we should add the maximum. We should figure out what the maximum possible sum for 7 is, and what the minimum. We should figure out what the minimum possible sum for 7 is. We should figure out what the maximum possible sum for 6 is. So if it was this 6 cells that add to be 37, then this would be a 6. Ooh, let's see. This would be a 6. So you would need to add to be 31. We wouldn't be allowed to use 6. We're interested in the maximum. So in this case, let's see. What did we say? We said if this was a 6, maybe I should fill it in, although I don't know if that's a good idea. Filling it in is just going to cause more confusion. But if you're a 6, then the maximum that you could be is 9. Then I could have a 4. Then I could have an 8. Then I could have a 3. That actually doesn't work. If you were a 6, and you were a 9, then you would have to be an 8. You could be a maximum 7. You could be a maximum 4, and then you would be a maximum 3. This is sort of like dealing with the maximums. But what is the max? This is the maximum sum that could go, I think, in these 6 cells. And that maximum sum turns out to be what? So this is 10. This is 18 together. 22, 31, 37. If you're a 6, if you were a 6, then there's only one way. Maybe these digits are rearranged a little bit. Maybe these digits would be rearranged a little bit. But then there's only one way of making the column, I think. I think we would need to use the maximums in every one. Yeah, something like that. If you're a 6, then the maximum possible sum I could possibly have would be 37. Let's see what happens when you're a 7. What is the minimum possible sum that you could be? If you were a 7, then it would be possible for you to be a 6. Then you would need to, hold on a second. Oh no. I'm realizing that the orange and the yellow need to add to 10. Just in any situation. Maybe I shouldn't have done that thing with the 6, but you certainly add to 10. You certainly add to 10. So if this was going to be a 7, you certainly add to 10, and orange and a yellow certainly adds to 10. A blue and a gray certainly adds to 10. That's, I think, how you do this. That's how you do this. We have that definitely a blue and a gray cell add to 10, so you two must add to 10. We also have that an orange and a yellow cell must add to 10, so you must add to 10. And then you must add to 10 too. So if you think about what happens if there's a 7 in here, we would need these 7 numbers to add to 37. These 6 numbers add to 30, which would mean that the missing piece there would need to be a 7, but that's not allowed because it would contradict with the 7 down here. So what we have figured out through all of that is that you must be a 6. In fact, every place that we see a gray cell, it must be a 6. Okay. Oh. Now gray pairs with blue to make 10, so every place that we see a blue cell, it needs to be 4. Oh, that was the wrong thing. Everywhere that we see a blue cell, we need to have 4. Now red needs to pair with 4 to make red needs to pair with blue to make 5, so everywhere we see a red cell, we need 1. Okay. Is that the extent of it? Now you must be a 2 and a 3 somewhere. Let's remove this. Everywhere we see a yellow and everywhere we see a green, you must be the numbers 2 and 3. Which means orange is not allowed to be a 9 anymore. Orange can only be a 2 or an 8, because orange needs to pair with a 7 or an 8. Because orange needs to pair with yellow to make orange needs to pair with yellow to make 10. Okay. So orange can only be a 7. Okay, so pink needs to pair with red to make 10. So this means pink needs to be 9. What did I just do? I only want you. Pink must be 9, so you're not allowed to be a 9 anymore. Now we're still going. Orange needs to pair with yellow. Okay, so we only have a couple of numbers left. You need to be a 2 and a 3. Okay, so I think the black also needs to be 7 or 8. Everywhere we see a black, you must be a 7 or an 8. You must be a 7 or 8. You must be a 7 or 8. You must be a 7 or 8. I guess I'm just not, I'm not seeing what the final step is. Huh. Black must be 7 or 8. So anywhere we see a black, we know that it goes, we know that you're a 7 or an 8. White is 5, so you guys could be 5s. I don't see where the contradiction is. Orange needs to be a 7 and an 8 as well, because you need to pair with yellow to make 10. There's something about this that I'm just not seeing. What am I just not seeing? What am I just not seeing? It feels to me like there's more. There's only one solution to this puzzle, definitely. But somehow I feel like we've gotten ourselves in a situation where I could fill in some of the numbers. We need to figure out which of these goes where. Oh, well, what I should be doing is I should be applying the 37 rule. So you need to add to be 37. There are 6 here that need to be added to be 37. Now there are just 4 that must add to be 27. So now these 3 must add to be 18. You must add to be 18. And this means that you're not allowed to be a 5. You must add to be 18. I could have 7 and 8, and then 3. That's what's going on. All of the yellow cells need to be 3s. All of the blue cells need to be 2s. Now, all of the black cells need to be 8s. Except for these ones. Forget about those ones. All of the orange cells need to be 7s. And now, all of the black cells need to be 8s. All of the white cells need to be 5s. Am I messing something up here? You need to be an 8. Sorry, it's because of the sum rule. Now you need to be a 5, you need to be a 5, and you need to be an 8. And the solution is correct. 69 minutes and 35 seconds. That was a really fun puzzle to do. I am happy to be the 11,963rd solver in the last 270 days. I guess a lot of people have solved this one. Maybe there was just some easy solution that I didn't see, but the way that we handled it is we threw down tons and tons and tons of colors, and ultimately we were able to figure out this was a lot of fun. I did like this puzzle. I'll give it a heart. Yeah, thanks for the puzzle, Florian. Hope to do more.